Okay, so independent events. We've got a question here where we're going to start out with percents, and we want our answers as percents, but rounded to the nearest hundredth. Suppose an oil company stores oil in underground tanks. Two tanks, I and H, are selected at random to be checked for leaks, and these tanks were made in separate locations and maintained by different crews. This would suggest independent events, that whether they're going to be defective at that moment if you make them different places and different people checking. So probably independent. Tank 1 has a 5.23% chance of a leak, while tank 2, not I and H, but 1 and 2. Okay. Tank 2 has a 4.79% chance of a leak. If these are independent, then we can multiply, change those both to percents, from percents to decimals, and multiply, converting that to a percent by moving 2 to the right and then doing our rounding. That's less than a 1% chance. What about neither having a leak? Well, since tank 1 has a 5.23% chance of having a leak, that's going to be a 94.77% chance that it doesn't have a leak. And we can do the same for tank 2. Find the probabilities of those complements of what we originally mentioned. Those should also be independent. If you don't believe that, give me a moment and I'll show you another option. Multiply what we get after subtracting each from 1. Convert to a percent and round. Okay, well, again, if you don't believe that, let me do a little erasing here. Okay, we just found that the probability that both have a leak is 0.25%. Take that away from the 5.23% chance of having a leak for tank 1. We get 4.98%. The 0.25% was that both leak. The 4.98% is that tank 1 leaks, but tank 2 does not. Similarly, taking our 4.79% minus 0.25%, we get 4.54%. That's the probability tank 2 leaks, but tank 1 does not. The probability of at least one leaking. Remember, union is inclusive, so you could either have exactly one of them or both of them, i.e. at least one leaks would be the total. So, adding all three of those, including what's in the intersection, union is inclusive, I'm getting 9.77%. And if we subtract that from 100, that's going to be 90.23%. Since that's still in our sample space, but not within those circles, that's telling us that the probability of neither one leaking, 0 of them leak, is 90.23%. That's the same thing we came up with the other way. What that's telling us then is that although we said the event of tank 1 leaking and the event of tank 2 leaking were independent. Well, I said earlier, independence means whether A happens or not has no influence on whether B happens or not, and vice versa. So tank 1 not leaking and tank 2 not leaking, those are also independent events. And so with that stated, without using any Venn diagrams, here are two more examples similar. Basically, the idea is not only are A and B independent, if A and B are independent, then we get three more pairs. A and not B, not A and B, and not A and not B. As soon as you have one of those pairs being independent events, the other three pairs are independent events. Use that instead of Venn diagrams, and we're going to make the next two go very quickly. So you talk about calculators from two different companies. TI has a 2.25% chance of making a defective graphing calculator. Casio has a 3.92% chance of making a defective graphing calculator. I've just made up these numbers, no insult to either company. And we want to find out the probability that the TI one is defective while the Casio one is good. And since we have two different companies, this suggests independence. And I even say back here, if these events are independent, then what would be the probability? Okay, so we can use our multiplication rule for independent events. And in the second factor, we were given 3.92% is the probability that the Casio one is defective, but we want it to be good. So a complementary event there. Subtract that percent from 100%. Convert your percents to decimals. Multiply. Round to 4 places because we wanted the percent to the nearest hundredth of a percent. So 2.16% chance of that. And another thing about defectives, here making printers, two different plants. So what's the probability that only the one from the first plant is defective? It has a 1% chance. The defective one at the second plant has a 2.5% chance, but we want only the first plant to make a defective one. So just like with the TI versus Casio, the one at the second plant is working just fine. I converted 2.5% to 0.025 as a pure decimal, and I converted the 1% to 0.01 as well. Assuming independent events, which, well, same brand, but different plants, maybe we can make this assumption. Do the subtraction, and then multiply. Round to 4 places, and turn it into a percent. Now it's in hundredths of a percent. That's a less than a 1% chance. That's all I've got for now. Oh, no. I'm going to make one more.